In this video, we're going to go through three-step conversions, specifically grams to grams conversions. The essential question that we're going to be answering is how can the mass of one substance in a chemical reaction be used to determine the mass of another substance? So three-step conversions, specifically the grams to grams, three-step conversions follow this pattern. So you're going to start with grams of A, you will convert it to moles of A, then you'll use a mole ratio to convert it to moles of B, and then you use the molar mass to convert back to grams, but this time in substance B. So here's an example of a grams to grams three-step problem. It says if 7.27 grams of NH3 reacts, how many grams of H2O can be produced? So we always start with our given. So we have 7.27 grams of NH3. And we're going to need three total steps here. Okay, so step one, we're going to turn those grams into moles. So I'm going to need the molar mass of NH3, which is 17.04. That's how many grams of NH3 are in 1 mole of NH3. Next, we're going to use a mole ratio to go from NH3 to H2O. And we just use the coefficients. So for every 4 moles of NH3, we're going to produce 6 moles of H2O. The third step is going to be turning those moles back into grams. So for every 1 mole of H2O, the molar mass of water is 18.02 grams. All right, there we go. Okay, this looks absolutely terrible to put in our calculator. So we're going to start with the given. So 7.27. Okay, now we can enter this all at once, or we can do it in parts. So I'm going to show you both ways. 1 over 17.04 is going to be the same as dividing by 17.04. I'm going to hit enter after that step. So that's just the first part here. Now we want to multiply by 6 over 4. So I'm going to go times, I'm going to use parentheses, 6 over 4. And then finally, times 18.02 over 1 is just going to be times 18.02. Okay, so there's our answer. Now, I can also put this in as one continuous multiplication problem. So I'm going to show you that it will also give you the same answer. So 7.27, I'm going to enter all three fractions. So 1 over 17.04, close that up. The next one is going to be 6 over 4, close that up. And then finally, 18.02 over 1. Okay, so notice I get the same answer here. So 11.5 is going to be our answer because we want three significant figures here. So 11.5 is going to be our answer. And our units, if we cancel out, will be grams of H2O. All right, let's do another one. This one says, how many grams of aluminum are required to produce 7.5 grams of aluminum chloride? So we always start with our given. So 7.5 grams of aluminum chloride. I need 3 steps because I'm going to grams of something else. Okay, so I'm going to need the molar mass of aluminum chloride. I've already figured that out. It's 133.33 grams of aluminum chloride. That's how many grams are in 1 mole. We're going from aluminum chloride to aluminum. And notice it's a 2-to-2 ratio, or a 1-to-1 ratio. So for every 2 moles of aluminum chloride, I have 2 moles of aluminum. Now I need to go back from moles into grams. So for every 1 mole of aluminum, I'm going to need aluminum's molar mass, and that is 26.98. Okay. Now we just put this in our calculator. So we've got 7.5. 133.33 is in the denominator, times 2/2, which is the same as 1. And remember, if you multiply a number by 1, you're just going to get the same number. Times 26.98 over 1 is just going to be times 26.98. Okay, so there's our answer. Now, this time we only had 2 significant figures, so I'm going to report my answer as 1.5. And if I cancel units, I'll just be left with grams of aluminum. All right, let's do one more. At this point, it would be a good idea for you to pause the video and try working this one out on your own. I'm going to pause for just a few seconds here. At this point, I'm hoping you have tried to work this out. If not, you're going to just watch me do it. And that's fine too. So we're going to start with the given, which is going to be 6.4 grams of oxygen. So 6.24 grams of oxygen. We're going from oxygen to iron oxide, and we're going to grams of that. So we're going to need 3 steps since we're going from grams to grams. All right, so oxygen is 32 grams per mole. That's how many grams are in 1 mole of oxygen. And then we move on to a mole ratio. So for every 3 moles of oxygen, we have 2 moles of iron oxide. And then to go back to grams, for every 1 mole of iron oxide, I've already computed the molar mass here. It is 159.7 like that. All right, let's plug this into our calculator. So we have 6.24 divided by 32. Next is my mole ratio, so times 2/3. And then times 159.7. Okay. I get 20.761. I want to go to 3 sig figs, so I would report my answer as 20.8. And my units are going to be grams of iron oxide. And that's it. That's how you do 3-step conversions.